to 6 million persons use the tunnel in a single year. But travel between Windsor and Detroit hasn't always been this easy. Let's turn back the pages of history. Back to a time in the 18 and 1900s when ferry boats, hooting and tooting their way around river freight traffic, took as long as 10 minutes to get folks from one country. Back to a time when Fred Martin, a Salvation Army captain in Windsor, dreamed of building a great underwater tunnel to connect the bustling downtown areas of Detroit and Windsor. Mr. Martin lived to see his dream come true. Thanks to his determination and $26 million worth of private bank financing, tunnel construction began in June of 1928, when the dredge Gladiator raised the first bucket of mud from the Detroit River at the point where the tunnel would eventually lie. 3 separate tunneling methods were used to construct different sections of the tunnel. The open cut method, the trench and tube method, and the shield-driven method. All 3 were begun almost simultaneously, and the completion of each required careful scheduling so that all the sections could be united at about the same time. For the land approaches at either end of the tunnel, the open cut method was used. Workers simply cut a trench to a maximum depth of 53 feet and erected a box-type structure of steel and concrete, which subsequently was covered over with earth. The Canadian entrance was built in a straight line, which sloped gradually to the harbor line. The American entrance had to be built in a gradually descending spiral pattern because there was not enough undeveloped land available in Detroit for a straight line entrance. The middle or underwater section of the tunnel was the most spectacular of all the tunnel operations. It was constructed by the trench and tube method. The operation entailed the construction of 9 gigantic tubes built of steel on dry land outside of Windsor. Canal-like trenches were dredged out along the shore into which the tubes would eventually be launched from wooden launchways. In October 1928, the steel for the first of the tube sections was put into place. The steel plates, 3/8 of an inch thick, were stiffened with octagonal steel collars inside and out. All the plates were welded, riveted, and tested to ensure that each section was watertight. Extensive use of electrical welding, then a relatively new technology, enhanced the reliability of watertight seals. The ends of the tubes had to be sealed prior to launching into the canal. Special 10 by 10 watertight timber bulkheads were built for this purpose. The bulkheads were backed up by steel trusses and covered by inch-thick sheeting for water tightness. 8 separate layers of waterproofing were applied. Finally, to form the base of the tube, concrete was poured into wooden forms which were constructed along the bottom of the tube. This also served as a keel to help stabilize the tube when afloat. When completed, the tube section measured 31 feet across and 248 feet long. Tube A was launched first. The launching was a dismal failure. The canal had not been dredged deep enough for the tube to float. Workers looked on helplessly as the tube became immediately mired in the mud. To overcome this temporary setback, hollow wood pontoons had to be constructed, and the area to the side of the tube was dredged deeper. Once the pontoons were filled with water, they were sunk, then attached to the tube. Then the pontoons were pumped out, and as expected, the extra buoyancy from the pontoons helped float the tube.
So they let the water come back.
After launching, the tube was towed to a deeper slip, where more wooden forms were constructed around the sides and top of the tube. Concrete for the interior walls and roadway was also poured at this stage. The concrete was poured over reinforcing rods and steel forms, which held it in position until it hardened. When completely concreted, the circumference of each steel tube eventually was surrounded by a wall of interior and exterior concrete 36 inches to 42 inches thick. During the winter, construction continued on the remaining 8 tubes. All 8 were launched successfully and towed into the deeper slips for concreting. While the tubes were being readied, 6 miles upstream, dredging barges began the process of digging through the stiff gray clay at the bottom of the Detroit River. They were preparing a trench into which the underwater tube sections would eventually be sunk. When completed, the trench at its greatest depth was 85 feet below the surface of the water, 20 feet across at the bottom, and 90 feet across at the top. Just prior to sinking the tubes, a sand bed was prepared in the bottom of the trench to correct the grade. For this process, a special leveling device was designed. It consisted of a hollow rectangular raft of steel pontoons. Rails were placed on top of the pontoons, and a special carriage traveled back and forth over them, acting as a sweeper for the sand bed. The successful sinking of the tubes was largely due to the development of this ingenious device, which ensured that the sand bed was placed with great accuracy. It took 4 tugs about 3 hours to tow each tube upstream for final concreting and sinking. The balance of the outside layer of concrete was applied at an anchorage point about 300 feet above where the trench was being prepared. At that point, each completely concreted tube weighed 8,000 tons and was submerged about a foot below the surface of the water. Before the tube was sunk, tall masts were fastened to each end to serve as guides for the engineers to align the tube into position. A buoyancy scow was positioned over the submerged tube, and cables were connected to the tube ends. Blocks of concrete were applied to the ends of the tube to sink it into the waiting trench.